Hello guys, now we will see how dynamic polymorphism is achieved in C++. So using virtual function we can achieve dynamic polymorphism, but in background what happens in compiler, how this function binding happens during runtime, how this is achieved. So let's see how that happens. So for achieving uh, dynamic polymorphism we need to have virtual function. So let's remove this virtual function and we will create new two classes. One is base and one is derived, and derived is inherited from base, and both will override this. In base class I am having fun function, and derived it is overridden. So now let's see what is the size of the class. It's just an empty class. So the size of the empty class will be 1. By default in C++, the size of, if we use size of operator and if we give the class name, obviously it will give the size of the object for that uh, class. So here it is not having any data member. So the it will have size as 1. In C++, we have this size of as 1. It's not 0, it will be 1 always for empty class. So similarly we will check for derived. So derived also it will be same. So 1. If we see it's 1 1. So some base is 1 and derived is 1. So now we will just add virtual here. Let's see what is the size. Okay. By adding virtual. See, now it became 8 8. We didn't add any data member, but how it became 8? So something is getting added, some member is getting added. So if you see the size is increased, so some member is getting added by adding virtual. So internally something is happening. Let's see what is happening. So if we declare any function as virtual, the class will create a virtual table for that class. So virtual table is nothing but a static array which will contain a list of function pointers for the all virtual functions declared in that class. So that is a virtual table. So base is having one virtual function, so a virtual table for base will be created. And derived also we didn't declare virtual, but by default it will become virtual because we have overridden the virtual function. So here also derived is also having a virtual function. So here also there will be one virtual table will be created. So if we have any virtual function, a virtual table for that class will be created, and what that virtual table will contain? A list of function pointers for all the virtual functions available in that class. Okay. So here it becomes fun becomes automatically becomes virtual. If we don't override this fun also, this derived will have the virtual table. Why? Because it is derived from base. So base is having virtual. So obviously this derived will also have a function fun that is virtual. So if we override or we don't override that virtual function, if we derive from base class which has some virtual function, obviously the derived class will also have a virtual table. So if you see, I have deleted this one, then also we are having it. So a virtual table will be created for all classes which have virtual function. This is virtual table. And what that virtual table will have, a virtual table will have a list of function pointers with a location of the function pointers for the all virtual functions available in that class. Okay, so now why it is 8? It is, this 8 is not the size of virtual table. We have another, it is basically size of object. So object is added some data member, so that size is 8. So we seen about virtual function. If we have virtual function, there will be virtual table. So if we have any virtual table, then for if we create any object, a virtual pointer will be created that will be pointing to the location of the virtual table of that class. Okay, so uh, internally it will be internal member, like it is an hidden member, that virtual pointer. How many objects we create? For each object there will be one virtual pointer created and it will be pointing to the virtual table. Okay, so that's why it is giving 8. 8 is the size of pointer. So that's why we are getting 8 now. So now we have seen virtual function, virtual table and virtual pointer. For virtual pointer will be created for each object for the class which is having virtual function. Virtual table will be created one for each class which is having a virtual function. Okay, so this is virtual function and virtual table. So now uh, in virtual table we have seen it will contain the location of each virtual function. So let's see how we can achieve dynamic polymorphism using that. So if we override that virtual function, in if we have the if you override that function in the derived class, then uh, how many virtual function we have? One. So virtual table will have one entry. If we override here, if we have some definition here, then in virtual in virtual table, for fun there will be one entry. There location of this function available in derived will be stored. If it is not defined, then the location of the previously defined location will be stored in this virtual table of derived. And in base we have one virtual function. So if we have definition for this location will be stored. And if it is not if it is derived from the previous function, that uh, previous class, that location will be stored in this virtual table. So you understood, I think. So you guys have understood, I think. Virtual table will have the memory location of the virtual functions. If it is not defined, it means previously in which base class it is defined, that address will be stored. If it is defined in the derived class, that address will be stored. So here, when I create a pointer of b equal to an object of derived, and if I call this function a virtual function, if I call a virtual function, first we don't directly call. In during runtime, it will check the virtual table of this object. This object is nothing but derived object. This pointer is of type base, but this object created is derived. So derived, it will first check the virtual table. So in virtual table there will be one entry for fun because fun is virtual function. So what is the memory location available? If it is overridden means that location will be called. If it is not overridden means base function will be called. So this is how we achieve dynamic polymorphism. So again I'm repeating. So we are creating a pointer of type base and we are creating an object of derived class. So while we calling any uh, virtual function before calling, sorry, for calling this it needs this function pointer address at the location of this function. So for this, if it is a virtual function, since it is this class have virtual function, it will be created a hidden pointer, virtual pointer. So that pointer will be locating to virtual table. First, it will look into the virtual table and it will check for the entry, fun entry. That fun entry, if it is overridden here, this the location of overridden function will be stored. If it is not overridden, the previously defined thing will be stored. So that location will be called here. So that's how we are achieving dynamic polymorphism. So basically, to achieve polymorphism, we need to declare a function as virtual function, and whenever we are declaring a virtual function, class will create one virtual table for that class and it will have entries for location of each virtual functions, and the derived class also will have the virtual table and it will also store the location of the virtual functions. If it is overridden means that function address will be stored. If it is not overridden means previously defined function memory location will be stored. So for each object, if it is having virtual function, a virtual pointer will be created. This virtual pointer will be pointing to the virtual table, and this assignment of virtual pointer will happen in constructor. It is handled by compiler. We don't need to worry about it is hidden. And while calling any function like virtual function, first it will check the virtual table, what is the location available, and that function will be called. So this is how we achieve dynamic polymorphism. I hope everyone understood how dynamic polymorphism is achieved and what is this virtual table and virtual pointer. Thank you.